So let's start with this chapter. Mm, this is chapter 10 in Fundamentals in Physical Geography of class 11 in the NCERT. So let's get into it. So you have already learned that air contains water vapor. It varies from 0 to 4% by the volume of, it varies from 0 to 4%. Okay, let's go through the structure of the chapter actually. Then we'll go through whole chapter topic by topic. So first of all, we have to, this is chapter is water in the atmosphere. Um, first, first topic is evaporation and condensation. Second topic is okay. The second topic goes as after the condensation, what happens to the water. So the form of water in, after the condition which it is present in the atmosphere or rather in the earth surface is the atmosphere. It is dew, as a frost, as a fog or mist, and as clouds. Also there are groups of cloud, like they are classified as a density in the basis of their height, expansion, density, transparency, opaqueness. So clouds are grouped under four types. First one is cirrus, cumulus, stratus, nimbus. Yes, the nimbus is the same one which Goku's travel. And the next is combination of these four clouds give rise to following high clouds. Okay, this is the same thing. It's just saying about the middle cloud. Okay, so we'll read about it. This topic is precipitation. This is the main topic. Under the precipitation, we have types of rainfall. The first is convectional rainfall, uh, orographic rainfall, next is cyclonic rainfall. And this is kind of a combination of these four types give rise to the following. These four basis type can give rise to following types of cloud. High clouds. Okay, in high clouds there is cirrostratus, cirrocumulus. Okay, these are based on the height, classified based on the height. So the clouds in very high altitude are called cirrostratus and cirrocumulus. Next one is in the middle. There is altostratus, and second is altocumulus, and lastly the lowest ones is stratocumulus and nimbostratus. And cloud with extensive vertical development, cumulus and cumulo, cumulon, cumulonimbus. Okay, so these are the types. Let's get ahead. Okay, slightly cyclonic rain. Oh, so this chapter is very small. Okay, I think this hardly take half an hour and all. So the water vapor, it varies from 0 to 4% by the volume in atmosphere. It's 0 to 4%. Since this is not a keyword, we'll write it. We'll mark it in a green one. Percent by volume of atmosphere. And plays a very important role in weather phenomena. Water present in the atmosphere in three forms, namely gaseous, liquid, and solid. The moisture in the atmosphere is derived from. Second. Okay, where were we? There is a continuous exchange. This moisture in the atmosphere is derived from water bodies to evaporation, from plant to transpiration. Thus, there is a continuous exchange of water between atmosphere, the ocean, and the continent through the process of evaporation, transpiration, condensation, and precipitation. Water vapor present in the air is known as humidity. It is expressed quantitatively in different ways. The actual amount of water vapor present in the atmosphere is known as absolute humidity. So it is the water vapor, basically the water vapor present in air is called humidity, but the absolute value of the water vapor present in the atmosphere, the absolute amount of water, is called absolute humidity. It is the weight of water vapor per unit volume of air. Okay, it's the weight of water per unit volume. It is weight of water vapor per unit volume of air, and it is expressed in gram per cubic meter. The ability of air to hold water vapor depends entirely on its temperature. The absolute humidity differ from place to place on the surface of Earth. The percentage of moisture present in the atmosphere compared to its full capacity at a given temperature is known as relative humidity. So the percentage of moisture. Let's mark this as like a keyword. The percentage of moisture present in the atmosphere compared to its full capacity at a given temperature is known as. So is known as relative humidity. With the change of air temperature, the capacity to retain moisture increases. Change of air temperature. Okay, but with the change of air temperature, the capacity to retain moisture increases or decreases, and the relative humidity is also affected. And is also affected. Okay, it is greater over ocean and least over continents. The air containing moisture to its full capacity at a given temperature is said to be saturated. So the air containing moisture to its full capacity at a given temperature is called saturated air. Saturated. It means that the air at a given temperature is incapable of holding any more additional amount of moisture at that stage. The temperature at which the saturation occurs in a given sample of air is known as dew point. This is very good definition. The temperature at which saturation occurs, saturation maximum, okay, is known as dew point. Evaporation and condensation. The amount of water vapor in the atmosphere is added and withdrawn to evaporation condensation. The amount of water vapor in the atmosphere is added or withdrawn due to evaporation and condensation respectively. 1 minute. The amount of water vapor in the atmosphere is added or withdrawn due to evaporation and condensation respectively. So evaporation is a process by which water is transformed from liquid to gaseous state. The heat is the main cause for evaporation. The temperature at which the water starts evaporating is referred. This is also a keyword, latent heat. Vaporization. Increase in temperature increase water absorption and retention capacity of a given parcel of air. Increase in temperature increases water absorption. So increase in temperature increases water absorption and retention capacity of a given parcel of air. So, okay, got it. That's why, like in steam, for example, steam is also an example. Like in steam of in in cold air, water will be scarce, but in steam, like steam, there is water is much denser. Okay, that could be an example. Also, okay, moving on. Ingredient also okay. Similarly, if moisture content is low, air has potential of absorbing and retaining moisture. Okay, the movement of air replaces the saturation layer with unsaturated layer, and the greater the movement of air, the greater the evaporation. This is also one. Greater the movement of air, that is, greater is the evaporation. Transformation of water into Transformation of water vapor into water is called condensation. Condensation is caused by the loss of heat. It's caused by loss of heat. No, this is a keyword, not a. This is caused by loss of heat. Hmm. When the moist air is cooled, it may reach a level at when its capacity to hold water ceases. Then the excess water vapor condenses into liquid form. In free air, condensation results from cooling around very small particle termed as hygroscopic condensation nuclei. This is a very good term, hygroscopic condensation nuclei. In free air, condensation results from in free air condensation results from cooling around very small particles termed as hygroscopic condensation nuclei. Particles of dust, smoke, salt from the ocean are particularly good nuclei. Particles of dust, smoke, salt from ocean are particularly good nuclei because they absorb water. So as we any impurity in water, just like particles, are very good are very good nuclide because they absorb water, and else they can form crystal also from that. And clouds, mainly clouds. Condensation also take place when the moist air comes in contact with some colder object. Mm, and it may take place when the temperature is close to dew point. When temperature it may also take place when temperature is close to dew point. Temperature is close to dew point. This is a good point to remember. Okay, condensation therefore depends upon the amount of cooling and relative humidity of air. Condensation is influenced by the volume of air, temperature, pressure, and humidity. So condensation is this is a let me okay. The condensation is there for condensation is therefore depends upon the amounts of cooling and relative humidity of air. Condensation is influenced by the volume of air, temperature, pressure, and humidity. Is air, temperature, pressure, and humidity. Condensation term condensation takes place when the temperature of air is reduced to dew point with its volume remaining constant. when both the volume and the temperature are reduced. Where is the third point? This is actually, I think the third point is missing. Okay, when the moisture is added to the air through evaporation. So we have 3 points basically. Okay, condensation influence the volume air near when the temperature of air reduced from the dew point, reduced to the dew point, with its volume remaining constant. So basically this one. And when the volume and the temperature reduce, okay, and when, okay, I'm using a wrong pen. When the volume and temperature reduce, and when moisture is added to the air through evaporation. Okay. Most favorable condition for condensation is a decrease in the air temperature. Okay. After condensation, the water vapor or the moisture in the atmosphere take one of the following forms. First, it can be a dew, it can be a frost, it can be a fog and cloud. Form of condensation can be classified on the basis of temperature and location. Condensation taking place when a dew point is lower than the freezing point is known as higher than known as lower than the freezing point as well as higher than the freezing point. Okay. When the moisture is deposited in the form of water droplet or on cooler surface of solid objects. When the moisture is deposited in the form of water droplet on cooler surface of solid object rather than the nuclei, in the air in the air above the surfaces, such as shown. Let's read it once again. When the moisture is deposited in the form of water droplet on a cooler surface of solid object like stone, grass blade, plants. Basically, in the morning, when you step out, you will see some water droplet on grasses and all. That's particularly tube. The ideal condition for the formation is very clear sky. So let's mark this. The ideal condition are for the formation of clear sky, calm air, high relative humidity, and cold and long nights. For the formation of dew, it is necessary that dew point is above freezing point. Okay. The first. Okay. What is it? It is necessary for the dew point is that the dew point is above. The dew point is above the freezing point. Okay. Let's go to the next one. The frost forms on the cold surface when condensation takes place below the freezing point. This is above the freezing point. This is below the freezing point. Okay. This is below the freezing point. That is 0 degree. That is dew point. That is dew point or at or below the freezing point. The excess moisture is deposited in the form of minute ice crystals instead of droplets. Okay, the ideal condition for the formation of frost are same as those of the formation of dew. That is clear sky, calm air, relative humidity, high relative humidity, cold and long nights. Okay, except now what is the exception? Except for the air temperature must be below the freezing point. So the air temperature must be below freezing point. So in this condition, air can be above air is above freezing point, not below, because it is written below freezing point. Okay, let's go to the next one. Fog and mist. When a temperature of an air mass containing a large quantity of water vapor falls, when a temperature of an air mass like large amount of air, in the last chapter we have read what is air mass. It is basically called strat. Yes, something like that. Yes. let's go through it. This atmospheric weather. What was it called? Like strata or something like that. No. Front. Yes, it is called a front. Exactly. But yeah, it is. Extratropical. What's declaration, circulation? Oh, maybe this chapter. I guess this is the one. The large mass of air. Let's see, the large mass of air is called a front. It is somewhere, but it is basically a large mass of air is called a front. Yeah. I read some. Oh, I'm so sorry, I'm not able to find it, but still, it is called a front, a large mass of air. So, moving on. It's called. It's containing a large. An air mass, yes, a large air mass containing a large. This air mass is called a front. Falls all of a sudden. Large quantity of vapor falls all of a sudden. Condensation takes place within itself on fine dust particles. So the fog is a cloud with its base at or near to the ground. Because of the fog and mist, the visibility becomes poor to zero. In urban and industrial centers, smoke provides plenty of nuclei which help the formation of fog or mist. Such condition when the fog is mixed with smoke is known as smog. The only difference between the mist and the fog is that the mist contains more moisture than fog. In mist, each nuclei contains a thick layer of moisture. Mists are frequent over mountain as the rising warm air up the slope meets the cold surface. Fog are drier than mist. They are prevalent where the warm current of air comes in contact with cold fog current. The fog are mini clouds in which condensation takes place around a nuclei provided by the dust, smoke, and the salt particles. Cloud is a mass of minute. Clouds are mass of minute water droplet as thin crystal of ice formed by condensation. So clouds are basically a mass of minute water droplets or tiny crystals of ice formed by the condensation of the water vapor in the free air at a considerable elevation. As the clouds are formed at some height over the surface of Earth, they take various shape according to their height, expansion, density, transparency, or opaqueness. Clouds are grouped under four types: cirrus, cumulus, stratus, and nimbus. Cirrus clouds are formed at the altitude of 8,000 to 12,000, basically 8 kilometers to 12 kilometers. They are thin, detached clouds, have feathery appearance. They are always white in color. Cumulus clouds look like cotton wool. They are generally formed at a height of 4,000 to 7,000 meters. So sorry. They exist in patches and can be seen scattered here and there. They have a flat base, so they exist in patches, can be seen scattered here and there, and have flat base. And the cirrus has feathery appearance, white, always white. Stratus, as their name implies, these are layered clouds covering large portion of the sky. These clouds are generally formed due to either due to loss of heat or mixing of air masses with different temperature. Nimbus are black or nimbus clouds are black or grey. Nimbus clouds are black or dark grey. They form in middle layer or very near to the surface. Nimbus are black or dark grey. They form at the middle level or very near to the surface Okay, this can be a very near to surface of the earth. These are extremely dense and opaque to ray of sun. So extremely dense, opaque to ray of sun. Sometimes the clouds are so low that they seem to touch the ground. Nimbus are shapeless mass of thick vapor. Shapeless masses of thick vapor. Okay. Identify the types of cloud which are given in the figure 0.1. These are basically nimbus because it's a dark. This is like feather-like, and it is existing in patches, and it doesn't have a straight base. So let me see. So these have flat bases. So these are cumulus, and stratus are these are layered clouds covering large portion of the sky. Covering large portion, they are generally formed either due to loss of it. Okay, I can also see some layers. One layer, two layers, second layer, but also these are flat bases, and these are feathered clouds like wool-like. So this wool-like and cirrus always in white. This is also white. This is white. I have a hobby, not hobby, like sometimes when I look at sky, I used to make like different faces and different kind of animal. Like this one looks like a dinosaur, something like this is his head, and this is its kind of tail, and this is a leg. Yeah, I can see shapes. Yeah, I can imagine shapes, and it's kind of fun with friends. Okay, moving on. A combination of these four types can give rise to the following types of clouds. High. First of high clouds. Let's mark a different color. It's for very high. I'm gonna mark it with this one. Let's go with okay, green. This is the middle one. So I have three in high clouds, two in middle layer, and two in low clouds, nimbostratus. This is the lowest one. Clouds with extensive vertical development, cumulus and cumulonimbus. Extremely vertical development. Okay, next topic is precipitation. Precipitation basically means raining. Okay, rainfall. The process of continuous condensation in a free air helps the condensed particle to grow in size, and when the ratios of the air fails to hold them against the force of the gravity, they falls on the Earth's surface. So the condensation of water vapor, the release of moisture, is known as precipitation. Release of moisture is known as condensation. This may take place in liquid or solid form. The precipitation in the form of water is called rainfall. When the temperature is lower than 0 degrees Celsius, precipitation takes place in the form of fine flakes in the snow. In the form of snow, it's called snowfall. The moisture released in the form of hexagonal crystal. This crystal forms the flake of the snow. Beside rain and snow, and other form of precipitation are sleet and hail. Through their lateral are limited in occurrence and are sporadic in time and space. Though the latter are limited to time, occurrence and are bound or sporadic in time and space. The sleet is a frozen raindrop and refrozen melted snow water. When a layer of air with the temperature above freezing points overlie a sub-freezing layer near the ground, precipitation takes place in the form of sleet, raindrops, which leaves the warm air. Encounters a cold air below. As a result, they solidify and reach the ground as small pellets of ice no bigger than the raindrop from which they are formed. So basically, it falls as a rain droplet. Okay, and here there is warm air, but as soon as this droplet reaches a certain layer that is very cold, so this droplet turns into ice, like solid ice, and their size are same as a droplet, like size are the same. Both sides are similar size. Okay, and this is called sheet. Basically, this is what is called sheet. Moving on. This is called sheet. Precipitation which leaves the warm air encounter the colder air below. As a result, solidified or below. Sometimes a drop of rain after being released from the cloud becomes solidified into a small round solid piece of ice, which is when it reaches the earth is called hailstone. So sometimes what happens, the drop of rain after being released by the air becomes solidified into a small rounded piece of air. Like as soon as it becomes water droplet, it becomes a solid part, a rounded solid piece of ice, which when reaches the earth is called hailstorm. They are formed by the rainwater passing through the cold layer. Hailstorm has several concentric layers of ice over one another. Types of rainfall. On the basis for origin, the rainfall may be classified into three main types: conventional, orographic, and relief, and a cyclonic or frontal. Okay, this is what the frontal air is, like air masses, the cause of cyclone, which I have already got. Okay, conventional rainfall. On the air on being heated becomes light and rises up in convection current. As it rises, it expands and the loss of heat and loses heat, and consequently condensation takes place and cumulus clouds are formed. With thunder and lightning, heavy rainfall takes place, but this doesn't last long. Such rain is common in summer and in a hotter part of the day. It is very common in the equatorial region and interior part of continent, particularly in the northwestern hemisphere. So what is happening? This is very light and this is very. It takes a very heavy rainfall, but it doesn't last long. So what are the keywords? With thunder and lightning, heavy rainfall take place, but doesn't last, but not last so long. Next is orographic rain. When the saturated air mass comes across a mountain, it is forced to ascend, and as it rises, it expands. The temperature falls and the moisture is condensed. The chief characteristics of the rain is the windward slope. Receive windward slope, like this. When this basically this is a valley. Imagine this is a mountain. Okay, now imagine this is to be the mountain. So it is saying that the mountain which face the wind direction is this way. Okay, this is the wind direction to this. The mountain surface which is facing the wind direction, this like this part, it faces more rain compared to this one. The temperature falls and the moisture. The chief characteristic of the rain is the windward slope of the greater rainfall. After giving rain on the windward side, when these wind reaches the other slope, they descend and their temperature rises. Then their capacity to take moisture increases, and hence this leeward slope remains rainless and dry. The area situated on the leeward side, like the opposite that get less rainfall, is known as rain shallow area. So basically the opposite side, it's called rain shallow area. Also it is also known as rain relief, rain shadow. Okay, rain shadow area. And cyclonic rain, you have already read about the tropical cyclone and the cyclone in chapter 9. That's the previous chapter. Please consult chapter 9 to understand cyclone and rain. Okay. The world distribution of rainfall. Different parts of earth receive different amount of rainfall in the year, and that too in different seasons. In general, as we proceed from equator to the poles, rainfall goes on decreasing steadily. The coastal areas in the world receive great amount, so the most amount of rain is received by the coastal areas of the world. The coastal area of the world. I am so receive greater amount of rainfall than the interior continent. Also, as we go from the equator to the pole, the rain goes on decreasing steadily. Also, of the continent, the rainfall is more over the continent than on the land masses of the world. The rainfall is more over the continent, more over the ocean. The rainfall is more over the ocean than on the land mass of the world because of being great source of water. The rainfall is more over the ocean. Okay. Uh, okay, this is basically a common sense. Between the latitude 35 to 40 degree north and south, respectively, of the equator, the rain is heavier on the eastern coast. The rain is heavier on the eastern coast. So if we try to draw a map, okay, let's go on, draw a map. So it is saying this is the equator. latitude, this is a latitude, this is a 35, one is 35 degree north, yes, 40 degree north, and 60 degree north and south. Okay, 40 degree, okay, this is a 35, this is 40 degree north, this is a respectively, not written respectively, that's why it's getting I'm confused, and on the coast, rain side is heavier on the eastern coast, so it is saying that, imagine the earth is, this is India, imagine this is India, so this is the eastern coast, so the eastern coast of every part of the world is getting more rain and goes on decreasing toward the north, goes on decreasing toward the west, so when it goes toward the west, there is less rain. But between 45 to 65 degree north and south, 45 degree, that is 45 degree north, here is, if we go above, that's 45 degree, and here is 65 degrees south. Now of equator, due to the westerlies, the rainfall is received on the western margin of the continent, and goes on decreasing toward the due to westerlies. Okay, westerlies happens here and happen, yes. So in the equator region, we get greater rainfall in the eastern side or the eastern coast, but due to westerlies, that in these areas, basically the temperate regions or the almost the semi-tropical regions, they get most of the rainfall in the western side, the western side of the land masses or of the continent. Margin of the continent, yeah, receive the rainfall received on the western part of this and goes on decreasing toward the east, so the eastern side of the continent receive less rain compared to the western side in the westerlies, areas under the westerlies, that is continent under the westerlies. Okay, let's mark this. These are kind of between. First is and the equator. This is between the equator of north equator. The rain is heavier. But of south of first received in the western margin of the continent, goes on decreasing toward the east. Okay, whenever the mountain runs parallel to the coast, the rain is greater on the coastal plains, and rain is greater on the coastal plains on the windward side, and it increases toward the leeward side. Basically, this is due to orographic rain. This is rain shadow area. On the basis of the total amount of annual precipitation, the major precipitation regime of the world is identified as follows. The first one is equatorial belt. I think we are going to continue this in the next chapter, maybe, I guess. The windward slope of the mountain containing the western coast of the this is a long one. I don't need to. Of the western slope along the western coast in the cold temperate zone, and the coastal area of the monsoon land receive heavy rainfall per annum. The interior intercontinental area receive moderate rainfall varying from, so the per annum. The coastal area of the continent receives moderate amount of rainfall. The central part of the tropical land and the eastern and the interior part of the temperate land receive varying. I think we are going to read this more thoroughly. Areas lying in the rain shadow of the interior of the continent and the high latitude is very less rainfall, that is less than 50 centimeter per annum. Seasonal distribution of rainfall provides an important aspect to judge its effectiveness. In some regional rainfall is distributed evenly throughout the year, such as in equatorial belt and in the western part of the cool temperate region. Which of the following is the most important constituent of the atmosphere of the human being? Okay, most important constituent is water vapor. For human being, actually most important is oxygen, I guess. Which is the most important constituent of atmosphere for I don't think much about the dust particles. This is oxygen. Which one of the following processes is responsible for transforming liquid into vapor? So the liquid in evaporation is the air that contains moisture to its full capacity is called absolute humidity. Let's confirm it. So here it is. Yes. The actual amount of vapor is okay. The weight, the humidity is relative humidity. The ability of air to hold water vapor depends on the absolute humidity differs from place to place. The water vapor is known as humidity. It expresses quantity, the actual amount of water vapor present in the atmosphere. The percent of moisture present in the atmosphere compared to its full capacity. Compared to its full capacity is relative. The change in air temperature, the change of air temperature capacity retain increases. The air containing moisture to its full capacity is said to be saturated. Containing moisture to its full, okay, it is called saturated air humidity. So it is called as absolute is the actual amount which is present. So the maximum amount is known as saturated air. Which one of the following is the highest? I think this is the highest one. Yeah, not. I think it is. These types of precipitation is dew, DEW. Yes. DEW, fog, and one is rainfall. Am I correct? Because these seems like condensation. Okay, where's precipitation? Yes, I got a precipitation. One is rainfall. Okay, here is a precipitation. Okay, all the types of precipitation are rainfall. Okay, the three types of one is sheet and haul and rainfall. A snowfall is also one kind of precipitation. the crystal snowflakes, snowfall, rainfall, sleet and hail. So three types of precipitation are, these are condensation, not precipitation. So sorry. Fog, so rainfall, snowfall, and and sheet and hail. Why does the amount of water vapor decreases with altitude? As we go up, the temperature decreases. And as it decreases, the amount, its capacity to retain water vapors also decreases. So its retention capacity decreases. That's why the amount of water vapor decreases. That's why we no. Altitude decreases, temperature decreases, retention capacity is also decreases as the altitude increases. Yeah, this is the correct one. How clouds are formed? Clouds are formed by ice crystal, which is due to combining of how clouds are formed. Yeah, clouds are made from are minute from a droplet and tiny crystal of ice are formed by condensation of water in the field considerable elevation. As the clouds are formed at some height over the surface, they take various shapes. No, this is the cloud. This is the mass of minute water droplet and tiny ice crystal of ice formed by condensation of water vapor. So it is formed by condensation of water vapor in free air at a considerable elevation. So this is is formed by condensation of water vapor at a considerable. Cloud is a mass of minus. So minute water mass of minute water water tiny issue. Okay, this is one. What we have next? Discuss the silent feature of world distribution of precipitation. Okay, this is one distribution of precipitation. Basically, we have to make a rough diagram. We can draw westerlies, which is responsible for the rainfall from the western side to the eastern side. As from western side to eastern side, it decreases, and in the equator from the eastern side to the western side, so it decreases from the as it goes to the western coast of the continent, and in the temperate region or this region, westerlies, it is opposite. So we have to explain that, and also for the equatorial belt we have to explain this on the basis of annual rainfall. We have to explain. Just roughly count the amount of word. Like 150 words are there, right? It's again 1, 2, 3, 4, 5, 6, 7, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 14. If you completely memorize this, we'll get 150 words. Okay, world climate and climate change. This is the next chapter, that is chapter 11. This chapter is too big. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is 8 pages long. This will take about 1.5 hours to complete, more than that. So let's get into it. Okay, let's start. The world climate and the climate change. The world climate can be studied by organizing information and data on climate and synthesizing. The world climate can be studied by organizing information and data on climate and synthesizing them into smaller units for easy understanding. So, easy understanding, description and analysis. The three broad approaches have been adopted for classifying climates. They are empirical, genetic, and applied. Empirical classification is based on observed data. Empirical classification is based on observed data. Empirical classification is based on observed data, particularly on temperature and precipitation. So, okay, this is going on. Genetic classification attempts to organize climate according to their cause, applied uh, classification for specified purpose. Okay, I'm going to take a break and I will continue from this. So Köppen's scheme of classification of climate. Next is tropical. Okay, let's go through the structure of the chapter. Then we'll go to the chapter. Okay, the first table is giving the climate group according to Köppen's. A for tropical, B for dry climate, C for warm temperate, and D for cold snow forest climate, and lastly the cold climate. Okay, the next one is, okay, we have one more types of climate. Okay, these are the further classification of this, and it has given some code. Okay, wet, F for wet, M for monsoon, wet and dry, SW, wet and dry. Okay, steep desert, steppe, mid latitude desert. Okay, FA, that was subtropical. We have one more, tropical. F for wet, so FA is less wet. S for subtropical. Okay, S is for summer, west coast. So F is for wet, so west coast is wet. B is for coast. No, dry season, warm and cool summer. Okay, next one is F is for wet, humid, that's why. Okay, the humid is taken as wet. Okay, subarctic, W here, wet and dry. Winter very dry and very severe, but okay, W is taken as dry, winter dry season. Okay, there is no, it is not a tropical one, that's why. I mean, it is a tropical one, but in winter there is no moisture in air, that's why the winter is dry. And here similarly, it is given as a tropic, W is given as a wet, but due to it is cold forest, that's why there is no moisture in the air, that's why it is kind of, I have to see the Amit Sen Gupta's video to better understanding. Okay, the first group is tropical humid climate. Next one is B is dry climate. Again, we have further classification of substeep. It is the same thing that as we have seen in the table. Snow, cold snowfall, climate change, cause of climate change, climate iteration in recent past. Next is global warming, greenhouse gas rising alarming, and lastly the exercise. So this chapter is 1, 2, 3, 4, 5, 6. Okay, 6 pages long. Let's get into it. So Köppen's scheme of classification of climate. The most widely used classification for climate is the empirical climate classification scheme developed by V. Köppen. So this scheme is developed by V. Köppen. I think he is a German guy. Köppen identified a close relationship between the distribution of vegetation and climate. He selected certain values of temperature and precipitation and related them to the distribution of vegetation and used these values for classifying the climates. It is an empirical classification based on mean annual and mean monthly temperature and precipitation data. He introduced the use of capital and the small letter to designate climatic group and types. So we have five groups, and further their types. So tropical has types. This dry climate has types. Warm temperate have type. Cold snow forest climate has types, and even the cold climate has its types. So he introduced the capital letter and small letter to designate climatic group and the types. Although developed in 1918 and modified over a period of time, Köppen's scheme is still popular and in use. Köppen recognized the five major climatic group for five major climatic group. Four of them are based on temperature and one on precipitation. So let's guess which is precipitation. I think dry climate is based on precipitation. Because yes. Table 11.1 lists the climatic group, and there's always something wrong with the. Oh no, let's correct this time. Okay, climatic group and their characteristics according to Köppen. The capital letter A, C, D, E. A, C, D, E define humid climate, and B is dry climate. Okay, see, B is is a dry climate. So A, C, D, E is a delineate humid climates, and B is dry climate. Climatic groups are subdivided into types. Climatic groups are subdivided into types designated by small letter based on seasonality of precipitation and temperature characteristics. These seasons of dryness are indicated by small letter F, MBS, where the F corresponds to no dry season. So F is for no dry season, M is for monsoon climate, W is for winter dry season, and S is for summer. So the small letter A, B, C, D, E refers to degree of severity of temperature. So severity of temperature. So okay. Refers to severity of temperature. The B dry climate are subdivided into capital S for steppe and or for semi-arid and W for desert. Semi-arid is almost desert, but it gets more rainfall than the desert. There is some precipitation in arid regions. Okay, the steppe. The climatic types are listed in 11.2 of climatic. The distribution group and types is shown in 11.1. Okay. Let's go to it. The group A, this one, tropical humid climate. So A is tropical humid climate. Tropical humid climate exists between the Tropic of Cancer and Tropic of Capricorn. Okay, the sun being overheated throughout the year, the presence of inner tropical convergence zone (ITCZ)
ITCZ, makes the climate hot and humid. Annual range of temperature is very low and annual rainfall is high. The tropical group is divided into three types, that is AF, that is A is for wet, AOF is for wet, so tropical wet climate, MM for monsoon, the tropical monsoon climate, AW is for winter, the wet and dry climate. Okay, let's write it down. So let's go through F. F is for wet, M is for monsoon, SMON, SWON monsoon, and lastly we have W for dry winter. As this is happening in the tropical humid, that is tropical place, so we have dry and wet winter, or dry and wet climate. One minute. Potential evaporation exceeds precipitation. Okay, where were we? Okay, W is for, now S is for summer, and W is for winter dry, or dry winter season, dry winter. Okay, this is exactly season. Okay, characteristics. So this is no dry season, so it is completely wet. M is for monsoonal or short dry, so it is its characteristics. Okay, the next one, SS for steep, or ABCD. Okay, ABCD is refers to the degree of severity. Subdivided into, okay, S is for steep, like big as, this is the smallest. AW, okay, here we were. Tropical wet climate is found near the equator. The major area are Amazon basin in South America, Western Equatorial Africa, and the Iceland in East Indies. Significant amount of rainfall occurs in every month of the year as the thunder showers in the afternoon. The temperature is uniformly high and the annual range of temperature is negligible. So there is no range of almost, so temperature is almost similar throughout the year. Basically it is 18, 19 or 20 among these numbers, as it is tropical one. So that's why uniformly high and annual range of temperature. This annual range of temperature is negligible. It is uniformly high. The maximum temperature on any day is around 30 degrees Celsius, while the minimum temperature is, so the range is between, so it is given for the group A, not the group A, for the tropical wet climate, this one, we have a range of 20 to 30 degrees Celsius. Okay. Tropical evergreen forests with dense canopy covers and large biodiversity is found in this climate. Tropical monsoon climate, AM for monsoon, A for tropical. Okay, so this one. Monsoon tropical climate is found over the Indian subcontinent, and northeastern part of South America, and northern Australia. Heavy rainfall occurs mostly in summer. Winter is dry. Detailed climatic account for this types of the detailed climatic account of this climatic type is given in the book of India Physical Environment. Okay, I'll give it a read. After this, after this whole physical like foundational course, let's go. Now the next one or the last one, I guess. Yes, this is the last one among the tropicals. Tropical wet and dry climate occurs north and the south of AF type climatic region. So this happens at the AF occurs north and the south of AF type climatic region. So AF is like tropical wet climate, F for wet. So it is saying that imagine this is a tropical wet. This area has tropical wet climate. So it is saying it is happening just above it and just below it. Okay. So this is AW. This is AW, and this is AF. Tropical wet climate. Its border dry. Its border with dry climate on the western part of the continents, and CW and CEW on the eastern parts. C is for where is C for warm, F, warm and wet, and warm and winters. Okay, now winter dry. Not this one. This one. So these are not classified. Like exactly this is not classified, but okay, but understandable. Okay, extensive AW climate is found to the north. AW means tropical dry winter climate is wet and dry. To the north and the south part of the Amazon forest in Brazil adjoining of Bolivia and Paraguay in South America, Sudan and south of Central Africa. Annual rainfall in this climate is considerably less than an AF and AM climate type, and it's variable also. The wet season is shorter and the dry season is longer, with drought being more severe. Temperature is wet season is shorter, and the dry season is longer. With okay, as this is a dry winter climate, as W is for dry winter. We already read that. That's why it has less wet season, shorter, and the dry season is longer. Hence, the dry season. The drought being more severe. So the drought is severe here. Drought being more severe. Temperature is high throughout the year, and diurnal range of temperature are greatest in the dry season. So range of temperature is like greater than the dry season, that is in the winter season. So next is deciduous forest and trees shed grass occurring. So these are the examples of these types of climate areas basically. The next is dry climate. Dry climates are classified by very low rainfall that is not adequate for the growth of plant. Very low rainfall that is not adequate for the growth of plants. This climate covers a large area of the planet extending over large latitude from 15 to 60 north and south of equator at the let me give it a read once again. I'm not able to understand it completely. Dry climates are characterized by very low rainfall. So we have a very low rainfall here, low rainfalls, and that is not adequate for the growth of plant. These climates covers a large area of planet exceeding over large latitude from so exceeding over large latitudes from 15 to 60 north and south of the equator. At the low latitudes from 15 to 30, they occur in area of subtropical high, where the subsidence and the inversion of temperature do not produce rainfall. So the inversion of temperature do not produce rainfall. On the western margin of the continent adjoining the cold current, particularly over the west coast of South America, they extend more at equ- equatorwards, 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 and occurs on the coastland in the middle latitude from 35 to 60 north and the south of equator. They are confined to the interior of the continent, where the maritime humid wind do not reach and to the area often surrounded by the mountains. Basically, these areas are surrounded by mountains, and they are completely interior of the continent. So that's why, and also they are far away from the maritime, yes, maritime, like from the coast, from the water bodies. So the humid wind doesn't reach that area because it's far into inside the continent, and also due to mountain ranges that are blocking those humid winds. The climates are divided into steeps, steeps or the semi-arid climate and desert climate. So steep is into steeps. Okay, they are further subdivided into tropical steeps, subtropical steeps, and tropical subtropical deserts. At a latitude from 15 to 35 and the mid-latitude steeps, that is BSK, and mid-latitude desert BWK at the latitude between 35 to 60. Subtropical steeps BHS, subtropical desert BWH climates. Subtropical steeps and subtropical deserts have common precipitation and temperature characteristics. So these subtropical steeps and subtropical deserts have common precipitation and temperate characteristics. Located in the transition zone between the humid and dry climate, subtropical steppe receives slightly more rainfall than the desert. So subtropical has more rainfall than the desert, adequate enough for the growth of sparse grassland. The rainfall, so there is some kind of greenery, like small, not more, but like sparse, very less, but it is more than the desert, like subtropical desert. The rainfall in both climates are highly variable. The variability in the rainfall affect the life in the steppe much more than in the desert, more more often causing famine. So the variability of the life in the that subtropical subtropical where it is it's subtropical steppe subtropical yes subtropical steppe uh, is more like deadly, more famine than the desert area. So, let's see why. Rain occurs in short, intense thunderstorm in desert, and it is ineffective in building soil moisture. Fog is common in coastal desert bordering cold currents. Maximum temperature in summer is very high. The highest shade temperature was 58 degrees Celsius recorded at Al Aziziag. Okay, 50 was recorded at Al Aziziag, the highest. Libya, that is on Libya on 13 September 1922. The annual and the diurnal range of free temperature are also very high. So the range of temperature annually is very high. So the next one, warm temperate, that is mid latitude climate. It is okay. Warm temperate, that is mid latitude climate, extend from 30 to 50 of latitude, mainly on the eastern and the western margin of the continent. These climates generally have warm summers with mild winters. They are grouped into four types. The first is humid subtropical, that is dry in winter and hot in summer. Okay, humid subtropical. Okay, but humid. Okay, Mediterranean. Next is humid subtropical, that is no dry season and mild winter. Third, CFA, that is no dry season. So no dry season means there is a wet season. Humid subtropical. We have two humid subtropical. Okay, in one humid subtropical there is a dry in winter, and in one there is no dry in winter. Okay, got it. Marine west coast climate. The next is humid subtropical climate, CWA. Humid subtropical climate occurs poleward of Tropic of Cancer. Humid subtropical climate occurs poleward of Tropic of Cancer and Capricorn, mainly in the North Indian plains and South China interior plains. The climate is similar to AW climate, except the temperature in the winter is warm. Okay, the temperature in the winter is warm, so it is exactly same to AW. Uh, that is tropical dry climate. AW is dry, W is for dry winters. So tropical, so temperature is almost same. So humid tropical climate occurs poleward. So it occurs at poleward, that is at the top of can, Tropic of Cancer, and one is at the bottom of Tropic of Capricorn. Okay, Mediterranean, Mediterranean. Okay, warm tempered. I think it should be given in the bold. So this is given in the bold. This is also should have given in the bold colors. Okay, next one is as the name suggests, Mediterranean climate occurs in the Mediterranean Sea along with the west coast of continent in subtropical latitude between 30 to 40 latitude, that is central California, central Chile, along the coast in southeastern and southwestern Australia. This area comes under the influence of subtropical high in summer and westerly winds in the winter. And the climate is characterized by hot, dry summer, mild rainy winters. Monthly average temperature in summer is around 25 degrees Celsius. So there is not much that is. So that occurs as Central California. The climate is characterized by hot summer, mildly monthly. Average temperature in summers is around average temperature is 25 degrees Celsius, and in winter is below 10 degrees Celsius. The annual precipitation range is 35 to 90 centimeters, not much. So Mediterranean S is for summer, I guess. Yes, it is a summer temperature. So this summer comes under influence of subtropical high in the summer and the westerly winds in winter. Next is the third one is humid subtropical climate. Okay, this one is FE. F is for this is a wet climate. Subtropical climate lies on the eastern part of the continent in the subtropical latitude. In this region, air masses are generally unstable and causes rainfall throughout the year. They occur in eastern United States of America, southern and western China, southern Japan, northeastern Argentina, coastal South Africa, eastern coast of Australia. The annual range of precipitation varies from 75 to 150 centimeter. Thunderstorm in summer and frontal precipitation in winter are common. Means basically, I think this is a common ground for, because it is America, right? We'll call it hurricane. Yeah, this is a common place for hurricane. Okay, mean common temperature in the summer is around 27 degrees Celsius, and in winter it varies from 5 to 12 degrees Celsius. The daily range of temperature is small. So, okay, marine west coast climate. Okay, marine west coast climate is located polewards from the Mediterranean climate on the west coast of the continent. The main area of main area the main area. One thing I have to do, like from the next chapter, I will add a map in this new section, a map of India, a world map, big, a big one, so that I can easily like navigate through all of these while teaching. So let me write it down. Attach ATTACH. Attach a map, that is world map. World map as well as map of Gia. Not in Australia and New Zealand, due to maritime influence, the temperature is moderate in winter. It is warmer for latitude. The mean temperature in summer ranges from 15 to 20 degrees Celsius. In the winter, it is 4 to 10 degrees Celsius annual, and the daily range of temperature is very small, similar to the previous one. Precipitation occurs throughout the year. The precipitation varies from 50 to 250 centimeter, much more than the previous one. So it is increasing. Okay, the second last one is the cold snow forest climate. The cold snow forest climate occurs in large continental areas in the northern hemisphere between 40 to 70 north latitude of Europe, Asia, and North America. Cold snow forest climates are divided into two types: DF, that is a wet kind of humid winter, that's a cold climate with a humid winter, and DW, cold climate with a dry winter. The severity of winter is much more pronounced in the higher latitude. So as we go up toward the north, our latitude also increases. So as the latitude increases, the severity of the winter is also increases. So the first one is DF, the wet one, with wet winter. Cool climate with humid winter. Oh yes, humid winter. Cold climate with humid winter occurs in polewards of the marine west of the coast climate, and mid-latitude steppe. The winter are cold and snowy. The frost-free season is short. Frost-free season is short. The annual range of temperature is very large, and the weather change is abrupt and short. Poleward winter is more severe. The cool climate with dry winter DW. The cool climate with dry winter occurs mainly in the northeastern Asia. The development of the pronounced winter and the pronounced winter anticyclone and its weakening in the summer sets in monsoon-like reversal of wind in this region. Let's read it once again. Cold climate with dry winter. So the cold climate with dry winter mainly occurs at the northeastern Asia. So northeastern Asia, like imagine this is Asia. It is saying that it occurs in this part. Okay, in this part, since this is north and this is the eastern part, so it occurs in this place. And weakenings, and it weakens in the summer, set in month, weaken in summer, set in monsoon, like reversal of monsoon in this. The polar summer temperature are lower. Okay, the polar, that is the upper limit, is lower, and the winter temperature extremely low, with many locations experiencing below freezing point temperature up for 7 months in a year. Wow. The precipitation occurs in summer, and the annual precipitation is lower than 5 to, so basically it is a very dry climate. So the place where the Mongols live, in the Russian place. I don't know what place this is called. Basically, these are the places where the nomadic clans of the Mongols live. Okay, nevertheless, let's go ahead. Polar climate. Polar climate exists poleward, that is 70 latitude. Polar climate consists of two types, tundra and ice caps, ET and EF. Tundra climate, ET. Tundra climate are so called after the types of vegetation, low growing mosses. Low growing mosses. T, T, E. I'm getting that E is a plural. E is for polar. What is T? T and F. That is capital. I haven't seen that. Okay, there is no FT is not given here. Okay. The tundra climate. Okay, T is for tundra and F is for tundra climate. So E is for polar tundra. Yes. So called the types of vegetation of low growing mosses, lichens, flowering plants. This region of permafrost where the subsoil is permanently frozen. The short growing winter and the water logging support only low growing plants. Short growing season, so short growing season. And the water logging support only the low growing plants. During summer, the tundra region have a very long duration of daylight. Okay, next is ice cap climate. The cap climate occurs of over interior Glassland and Antarctica. Even in summer, the temperature is below freezing point. This area receives very little precipitation. The snow and the ice get accumulated, and the mounting pressure causes the deformation of the ice sheet, and they break. And they break. The more they move as iceberg that floats on the Arctic and Antarctic water. Plateau, Plateau Station, Antarctica, 79° south, Portadius climate. Okay, so here we have only two types. This is also of two types. So that's climate change. Earlier chapter on the climate summarized our understanding of climate as it prevails now. The types of climate we experience now might be prevailing over the last 10,000 years with minor and occasional wide fluctuation. The planet Earth has witnessed many variations in climate since the beginning. Geological records show alteration of glacial and interglacial period. Geomorphic, geomorphical features, especially in high latitude, exhibit trace of advance and retreat of glaciers. The sediment deposit in a glacial lake also reveals occurrence of warm and cold period. The ring in the tree provides clue about the wet and the dry period. Historical record describes the varieties, vagaries describe the various in climate vagaries in climates. All this evidence indicate that the change in climate is natural and continuous process. Okay, it is a continuous process. India also witnessed alternate wet and dry period. Archaeological findings show that the Rajasthan desert experienced wet and cold climate around 8000 BC. The period 3000 to 1700 BC has much higher rainfall. From about 2000 to 1700 BC, this region was the center of Harappa civilization. Dry condition accentuated since then. Okay, in the geological, this is much. These region are past the center of Sierra. Dry season, the dry condition accentuated this since then. In the geological past, the Earth was formed some 500 to 300 millions year ago through the Cambrian, Ordovician, Silurian period. During the Pleistocene. Okay, this one is so much. This is so much new words I've seen during the Pleistocene, Pleistocene, Pleistocene epoch. Glacial and interglacial period occurred. The last major pre-glacial period was about 18,000 years ago. The present interglacial period started 10,000 years ago. So there is a complete cycle. Climate and recent past. Variability in the climate occurs all the time. The 90s decade of the last century witnessed an extreme weather event. In 1990 recorded the warmest temperature of the century and the sum of the worst flood around the world and the worst devastating drought in the Sahel region of the Sahara Desert from 1967 to 1977 is one such variability. Okay, the worst devastating drought in the Sahel. During the 1930s, severe drought occurred in southwestern Greater Plains of the United States, described as the Dust Bowl. In 1930, severe drought in the southwestern Greater Plains of the United States, described as the Dust Bowl. Historical record of crop yield or crop failure of floods and migration of people tells about the effect of changing climate. A number of times European witnessed warm, wet, cold and dry period. A significant episode were the warm and dry condition in the 10th and 11th century. When the Vikings settled in the Greenland, Europe witnessed little ice age from 1550 to 1850. About 1885 to 1940, world temperature showed an upward trend. After 1940, the rate of increase in temperature slowed down. Cause of climate change. The cause of climate change are many. They can be grouped in astronomical and terrestrial causes. The astronomical causes are the change in the solar output associated with the sunspot activity. So basically astronomical causes the change in the solar output associated with the sunspot activity. Sunspots are dark and cooler patches on the sun which increases and decreases in a cyclical manner. According to some meteorologists, when the number of sunspots increases, cooler and better weather and great storminess occurs. A decrease in sunspot number is associated with the warm and the drier condition. Yet these findings are not statistically significant. Another astronomical theory is the Milankovitch oscillation. Another oscillation is Milankovitch oscillation, which infers cycle in variation in the Earth's orbital characteristics around the Sun. The wobbling of the Earth and the change in the Earth's axial tilt. All these alter the amount of isolation received from the sun, which in turn might have been a bearing on the climate. Volcanism is considered as another cause for climate change. Volcanic eruption throws up a lot of aerosols in the atmosphere. These aerosols remain in the atmosphere for a considerable period of time, reducing the sun's radiation reaching the Earth's surface. After the recent Pinatubo and El Descent Pinatubo. volcanic and Alcyon volcanic eruption. The average temperature of the Earth fell to some extent for some years. The most important anthropogenic effect on climate is the increased trend in the concentration of greenhouse gas in the atmosphere, which is likely to cause global warming. The most important anthropogenic effect on the climate is increased trend in on the climate is the increased trend in the concentration of greenhouse gas in the atmosphere, which is likely to cause global warming. Okay, global warming. Okay, we have to. Okay, 2 more pages. Like 1.5 pages, basically. Global warming. Due to the presence of greenhouse gases, the atmosphere is behaving like greenhouse. The atmosphere also transmits the incoming solar radiation, but absorbs the vast majority of long-wave radiation emitted upward by the Earth's surface. The gases that absorb long-wave radiation are called greenhouse gases. So we receive rays in short wave, and we release that. The Earth releases that. The surface releases the radiation which it has absorbed in the form of long waves. This we have read in the previous chapters. The processes that warms the Earth are often collectively known as the greenhouse effect. The term greenhouse effect. Okay, this is under the box, so this is the most important thing in this chapter. Greenhouse is made up of glass. Greenhouse is made up of glass, the glass which is transparent to the incoming short wave, and the radiation is opaque to outgoing long wave radiation. The glass therefore allows more radiation and prevents long wave radiation going out the glass house, causing the temperature inside the glass structure warmer than the outside. When you enter a car or a bus during summer, where the windows are closed, you feel more heat than outside. Likewise, during the winter, vehicle with closed doors and windows remain warmer than the temperature outside. This is another example of greenhouse effect. So the greenhouse gases. The primary GH greenhouse gases of the concern today are carbon dioxide, chlorofluorocarbon, methane, nitrous oxide, ozone. Some gases such as nitric oxide and the carbon monoxide easily react with greenhouse gases and their effect concentration in the atmosphere and affect their concentration in the atmosphere. The effectiveness of any given greenhouse gas molecule will depend on the magnitude of the increase in its concentration, its lifetime in the atmosphere, and the wavelength of the radiation that it absorbs. The chlorofluorocarbon is highly effective. Ozone, which absorbs the ultraviolet radiation in the stratosphere, is very effective in absorbing the terrestrial radiation when it is present in the lower troposphere. Another important point to be noted is that the more time the greenhouse gas molecules remain in the atmosphere, the longer it will take for the Earth atmosphere system to recover from any changes brought by the latter. The largest concentration of greenhouse gas in the atmosphere is the carbon dioxide. The emission of CO2 commonly mainly from the fossil fuel combustion, forest and ocean are the sink of carbon dioxide. Forests use CO2 for their growth, so deforestation due to change in land use also increase the concentration of CO2. The time taken for the atmospheric CO2 to adjust to the change in a source to sink is 20 to 50 years. It is rising about 0.5% annually. Doubling of concentration of CO2 over pre-industrial level is used as an index for estimating the change in the climatic model. So what we are using pre-industrial level concentration of CO2 over the pre-industrial level as an index for estimating the change in the climate. Okay, chlorofluorocarbon are the products of human activity. Ozone layer occurs in stratosphere where the ultraviolet rays convert oxygen into ozone. Thus, ultraviolet rays do not reach the Earth's surface. The CFC, which drift into the stratosphere, destroy the ozone. Large depletion of ozone occurs over Antarctica. The depletion of ozone concentrate in the stratosphere is called ozone hole. This allows the ultraviolet rays to pass through the troposphere. International effort has been initiated for reducing the emission of greenhouse gas into the atmosphere. Most important one is the Kyoto Protocol, proclaimed in 1997. This protocol went into effect in 2005, ratified by 141 nations. Kyoto Protocol bound to the 35 industrial countries to reduce their emission by the year 2012 to 5% less than the level prevalent in the year 1990. The increased trend in the concentration of greenhouse gas in the atmosphere may in long run warm the earth up. Once the global warming sets in, it will be difficult to reverse it. The effect of global warming may not be uniform everywhere. Nevertheless, the adverse effect due to global warming will adversely affect the life support system. Will adversely affect the life support system. Um, Rise in the sea level due to melting of glaciers, ice caps, and the thermal expansion of the sea may inundates large part of the coastal area and Iceland, leading to social problems. This is another cause for serious concern for the world community. Efforts has been initiated to control the emission of greenhouse gas to arrest the trend toward global warming. Let us hope the world community respond to this challenge and adopt a lifestyle that leaves behind a livable world for the generation to come. One of the major concerns of the world today is global warming. Let us look at much the planet has warmed up from the temperature record. The annual average near the surface air temperature of the world is approximately 14 degrees Celsius. So this is the 14 degrees Celsius is the average temperature. An increase in trend in the temperature was discernible in 20th century. The greatest warming of the 20th century was during the two periods 1901 and 44 and 1977 to 99. Overreaching these two periods, the global temperature rose about 0.4 degrees Celsius. In between, there was a slight cooling, which was more marked in the northern hemisphere. The global average annual mean temperature at the end of 20th century was 0.6 above the recorded at the end of 19th century. The seventh warmest year during the 1856 and 2000 were recorded in the last decade, and the year 1998 was the warmest year, probably not only for the 20th century but also for the whole millennium. Gangotri is sinking 25 meters every year. Okay. Let's switch one of the following is suitable for the A types of climate. So A is high in rainfall all the month. If it be AF, then I can say it is mean temperature and replacement temperature. Mean monthly temperature all the month more than this every temperature of now. This is the mean temperature. Köppen system of classification of climate can be applied empirically. No, it is genetic. Empirically, no. Let's see. Also, genetic classification. Empirical based on observed data. Okay, this is the empirical classification based on observed data. They are empirical, genetic, and applied. Okay. So I guess all of them. So classification is empirical, genetic, and applied. All of three. Most of the air Most of the Indian peninsula will be grouped according to Köppen system. So Indian peninsula, I'll give it this one because it is humid as well as wet, but it's also monsoon. Most of Indian peninsula will be grouped according to the Köppen system under let's see under. Okay, we got it. So AF is for American Western Equatorial Africa and the island of East Indies significantly. Okay, so basically it is a evergreen forest which has continuous okay, this is the one. AM. Tropical monsoon climate is found in Indian subcontinent. So subcontinent is the peninsular region. Which of the following years is supposed to have recorded the warmest temperature? It is in 1990s in Libya, maybe. Yes, it is in Libya. Al Azizi, something like that. Al Azia, Azizi, yeah. It is in 1922. So it is in 1922. Which of the following years supposed to have recorded the warmest temperature all over the world, man? So all over the world. Okay, this is here. We have the year 1998 was the warmest year, and probably not only for the 20th century but for whole millennium. So we got our answer. Is this which of one of the following four types represents a humid climate? Which one of the following group? No idea. Which two climatic variable are used in Commons? Two climatic variables are used in Commons for classifying climates. Common variable, two types of climatic variable. That is, one is dry. Okay. Okay, one is humid, delineating humid climate and dry climate. Humid, basically humid and dry climate. So that's it. Types of climate. All are temperate and slow climates. Slow where the forest areas have very low temperature. Even the polar regions have the very low temperature. Okay, range of temperature you're saying. So we have the AF also. it has consistent almost negligible range of temperature throughout the air. And some more. What types of climatic condition would prevail if the sunspot increases? The sunspot increases, then cold climate will prevail, and if the sunspot decreases, then there will be dry climate.